the next part of the lesson for today, what we're looking at is, first of all, can we solve an equation where we're dealing with exponentials? And so, again, we're dealing with exponential equations, so we can actually solve these if we can get the bases to match. If we can't get the bases to match, well, then we're going to solve it a different way. So I'm going to show you two ways to solve. So if I can get the bases to match, that's going to be examples number 11 and 12, and that's how your worksheet starts out. So first of all, if you have the same base, therefore your exponents are going to be equal. So I'm going to look at 4 and 8. And if I think about 4 and 8, they're really based on what power? Power of what? Well, think about what power makes 4, what power makes 8? 2. Okay. So this is really, 4 is really 2 to what power? Squared, right, 2. Okay, and then I'm going to put the exponent outside. So it looks like that. So I have a 2 squared, that's really representing the 4. And then the exponent is outside, which is the x plus 1. And then to do the other part, let's think about 8. So 8 is really 2 to what power? Cubed, so to the 3. And then again, the other exponent is outside looking in here, so 2x plus 3. Now, the rule is, if they have the same base, then the exponents will have to be equal. Now, if you remember from polynomials, if there's parentheses, what do I do with my exponent? We multiply. So this is really 2 to the 2x plus 2, because I'm doing 2 times x, 2 times 1, got 2x plus 2, equals. Okay, now we have the other side. If there was nothing here there, then you would just set it equal to whatever the exponent is. But here there is some stuff outside, so we're going to have to multiply that out. So 3 times 2x, so that'd be 6x, and 3 times 3, which is 9. Since they have the same base, the exponents are equal, so now I can ignore the big 2's. So since they have the same base, I just set the exponents equal. And then we're back to normal with algebraic basic solving. So I'm going to subtract 2x both sides, and then subtract 9. So I'd have negative 7 equals 4x, divide by 4, negative 7/4. So there's my answer. So again, it's all about the base. If you can make the base match, make it match, because it makes your life a little bit easier. Okay. The hard part is for some students, they have to figure this out. That's the part where they struggle. So they have to think about what power that is. Okay. Our next example, we have an 8 and a 16. So those are also still bases of 2. So we'll still work with the 2. We already know how to do 8. That was 2 cubed. Outside will be the 2n. Okay, how are we going to represent 16? Still need a base of 2. 2 to the 4th. And then outside would be the n minus 3. Okay, everybody okay so far? So if you can make the bases match, like if you got one number that's like 25 and I got 125, then I know, oh, that's a base of 5. So you have to kind of look at that a little bit. And so again, I'm going to multiply, because again, if the exponent is outside the parentheses, these are going to get multiplied. So I'm going to have 2 to the 6n, and then 4 times n, which is 4n. 4 times negative 3 is negative 12. And again, since they have the same base of 2, I can drop the base and set the exponents equal to each other. And then subtract 4n both sides and divide by 2. So what do you think? We're not done yet. We're close. You went through the first part, so we're good. Well, what if the bases can't match? Oh, yes, we can do it. So anyway, so 11 and 12 is talking about if you can make the bases match, make the bases match. Okay, what if I can't? So I've got 3 examples where I can't make them match. So 6 and 442 is not a power of 6. There's nothing I can do with that. So what we're going to be using is not necessarily the change of base property, but we're going to be using the power property in a little bit. The power property, by the way, is if I take a log to an exponent, what you're going to have to do is if the number has an exponent on it, the exponent is actually going to go in front of the log. So that's using what we call the power property. So what that means is I can't get these bases to match. 6 is not going to match 442. So your first step is to log it. So we're going to log each side. So I'm going to have log of 6x equals log of 442, because what I do to one side, I have to do to the other. Okay? Next, you see how the 6 has an exponent? I need to use the power property to take that exponent and put it to the front of that log. So this x will now get shifted to the front. So it'll be x log 6 equals log of 442. So notice it's making the exponent go away and not be an exponent anymore. All right. The x and the log of 6 are doing what to each other? So we're going to divide it, right? So we're having multiplication. So now we're going to divide. And so then I got x equals, and then now I just calculate. So these are going to be rounded to the thousandth place, just like what we were doing on our practice work from before. So we're just doing log of 442. Make sure you close those parentheses before you divide by the log of 6. And then if we round to the thousandth, that 6 is going to bump the 9, which is going to bump the other 9, which is going to bump the 3. So there it is. So 3.400. Because they went it to the thousandth place, so I put 2 zeros. Okay. So questions on, we got 2 more examples. Okay, next one. Let's stay focused so we can finish up. So for 14, you're going to do the same thing. 2.1 and 12.4 are not going to be a base of each other. So therefore, we're just going to do the log of each side. And by the way, if the bases would match, you still could do the log if you wanted to. So that is also an option. So we're going to have log of 2.1 to the x minus 1 equals the log of 12.4. So that's our first step. So your first step is always to log it. Second, look for that exponent now changing, because it's not going to become an exponent anymore. That's the purpose of logging. So now it's going to shift with the power property, and that exponent is going to go in front of the log. So that x minus 1 is now going to go in front of the log 2.1. So it's going to look like that. Just like before what we did with the x. And again, these are being multiplied. So I'm going to divide by the log of 2.1. Now, once I do my division, that's not going to be my final answer. And I would encourage you, by the way, don't round. So we're not going to round until we get to the very end. So we're going to take with our calculator, we're going to do the log of 12.4 divided by the log of 2.1. And I'm going to get 3.934 and some other lovely numbers after that. And so I don't want to bother writing that down too much. So I'm just going to add 1 to that. And so if I add 1, there's my answer. One more. Okay. All right, last one. So what if we have an exponent and that exponent has an exponent?
Do the same thing.
Yeah. So this one again, we would have our log, and then 5 to the x squared. And then we'd have log 50. So first again, log it each side. The exponent will come, we'll actually save that square root to the last step. You're right. But right now we're just going to move using the power property, put that exponent in front. And then again, get the x squared by itself. So we're going to divide by the log of 5. And again, you know, divide out the log of 50 divided by the log of 5, but then don't round it. I would just, you know, keep that value in your calculator. No, it's not going to work that way, Mikhail.
Why can't the logs cancel out?
They don't.
Let's go.
Because you're actually taking a logarithm to a number. So this is going to be 2 point. But I don't want to round it yet, because if you round your answer, then square root it, and then round it, that might just make it a little bit off. So I'm just going to leave that value in my calculator and then square root it, and then round. So I'm going to get 1.559. And I'm done. Yes, worksheet. Okay, questions?
Is there a backside?
No.